Hello, and welcome to my PROCJAM talk. This talk is going to be about generative adversarial networks, which are networks that can generate content in the widest sense, and here I'm going to talk about how they can be applied to level generation. I'm not going to go into great detail of the method because there's already a lot of stuff out there on the internet. Here I'm going to focus specifically about how this method can be applied to level generation and what to look out for. So if that's something you're interested in, do listen on. A little bit about me. I'm Vanessa Volz, and I currently work at modl.ai as an AI researcher. Modl.ai is a small startup company based in Copenhagen in Denmark, and we provide AI solutions for the games industry. At the same time, I am also an honorary lecturer at the Game AI group at Queen Mary University in London. And I have worked with GANs quite a bit during my postdoc and my PhD. So what are GANs? As the name says, they're a generative model based on neural networks. And they've gained quite a bit of popularity recently. So it started mainly with the application to image generation, and you might have seen these really cool examples of people that are generated that don't exist. And more recently, they've also been applied quite a bit to level generation, for example, here for Mario levels. So, but how does that really work? It's an adversarial process. So you have two adversaries that are networks, but are in this case personalized. So let's imagine we have a generator that is forging levels, and the discriminator needs to figure out whether it's an original level or a forged one. So they are presented with a level, for example, one from Candy Crush Saga, and then they decide it's fake, and that's true. This is not a real level, and then they get a point. And conversely, if the presented level is real, then they decide it's fake, then the generator gets a point. And so both of these networks get feedback based on their performance, and then iteratively, they both get better at their respective tasks. And we've seen this can get quite good. But let's get into a bit more detail. If you just have a game, what do you start doing? Now, step one is to find a good representation. So in the case of Candy Crush Saga, for example, we decided on a grid representation with multiple layers. One issue was that there's actually a lot of different items in Candy Crush Saga, and this would not be possible to generate. So instead, we grouped these items into 6 different groups, and we just generate which group of item is in a specific position. So now if we get a level, we check, for example, which blockers there are. We mark them with a 1, and this is the layer of blockers. And then you have a one-hot encoding or a binary encoding. We did a similar thing when we were generating Mario levels, just that it's a bit easier because there's no overlays in this, but we also had more different items. One thing to look out for is if you choose a representation that allows for invalid or like anesthetic solutions, that can happen that the generator will actually come up with those. So in our original idea, we had a generator that came up with these broken pipes sometimes. And so instead, we chose a different representation where we had just one indicator for a pipe, and that gets built automatically. So there were no broken pipes, and all flying enemies, or like they were in the air, got wings to not have flying Goombas randomly in the air. So after you figured out a representation, you need to find some training data. And what we did for Mario, for example, is look at the video game level corpus, which I can highly recommend. There are a few different, albeit older games on there. And another thing that we did is we used a sliding window over each game level to produce more samples. Another tip I have here is to try to have some of the characteristics that you are desiring in the levels emphasized. So for example, we train separately on overworld and underground levels to not confuse the generator too much. So this way we were actually able to create stereotypical underground levels with ceilings on top, and overworld levels didn't have that. Otherwise, if we merged these two data sets, the generator got confused. And it's similar in Candy Crush Saga, where we just trained on vertically symmetric levels to encourage this characteristic more. So let's say now you have data and you can start your training. One thing that I didn't mention before is that the generator also gets an input. This is random noise, just a random vector of whatever size you choose, which then gets put into the network, and the output is of the same format as your chosen representation. So because the representations are the same, this can then be fed into the discriminator, who then gets to decide which ones are forged. And I guess this is rather obvious, but there are some existing implementations out there specifically for GANs, but also for game generation or level generation, which I just wanted to point to, which might be a good starting point. So as I just said, the input of the generator is actually a random vector. So once you have trained the generator, you can input different vectors and look at the output and play around a bit and see what you get. And here I recommend that you do this quite a bit and look in different areas of the latent space that is created by these vectors, because there can be quite some variety in the generated levels. As we see in the Candy Crush Saga example here, some are pretty good, some are not. But then also there are areas where the levels can be the same or very similar, as you see in the overlay of the Mario levels here. So I guess the remaining question is, should you do it? Well, that's not really easy to answer, and it really depends on the application. But what I can say is that GANs do have several strengths. For example, the generation is pretty quick. So if you have a problem where you need to generate a lot of levels quickly, that's a very good option. And it is fairly general, so you can create Candy Crush Saga levels or Mario levels or Zelda levels or whatnot. And this latent space that it creates inadvertently has very interesting properties, and there's a lot to be done with that as well. You can find similar levels, for example, by just looking at similar vectors. And one thing that it's very good at is finding specific patterns. So for example, our GAN figured out all the time that Goombas usually come in groups and that underground levels have ceilings. On the other hand, there are several weaknesses to this approach. So first, it does require quite a bit of preparation. You need to come up with a representation and find training data, and then actually train the models, which does take quite a bit of time. And then there's not really a guarantee about the characteristics of your output. You might not know exactly what levels you actually end up with. In addition, it is better suited for domains where it's not really important that you have exact symmetry, for example, because you're probably not going to ever be very exact. So for example, in this Candy Crush Saga level, there is this one tile that is a bit off that kind of throws you off a bit. Whereas in Mario, it doesn't really matter if there's an extra Goomba somewhere. But if you have more questions, please feel free to contact me on Twitter, for example. I'm going to try to keep an eye on it. And with that, I just wish you happy generating.